Take two, engineering 305. I am working the rectangle in torsion, running the same parameters that I ran it in Inventor, just because I don't have time to redo calcs. Let's go. Front plane. I'm going to make a sketch. I am putting a rectangle down like that. The center point of the rectangle is at the origin there. I'm going to make those coincident. Oh, look, that was so much easier. Sorry, I'm not mocking anybody else's software. Boy, this computer's really lagging. Point 375. Could you hear the difference between when I typed it and when it went in? 2 inches. I think I shut down like everything I could. You can't see the bottom of my screen, but this is really all I have running. Bloatware from other people. And then I'm going to extrude this 12 inches long. 12. All right, it's good. Simulation. Study. A new one. Yes. Scroll to the bottom. Where do I hit the OK? Oh, green mark. All right. I'm using inventor commands to try to move this thing around. Part, I am going to apply my favorite material, which is not, oh, there it is, 6061 T6. I should look at the material properties, but I'll do that later. Fixtures, I need a fixed geometry on this end. Boy, it's way behind. That's good. That was me using Inventor keyboard to move this thing around. Fixtures, external load, a torque. I think this is going to give me more trouble. I can put a torque on that face, and it needs to have an axis, and I don't have an axis right now. So I'm going to stop this right here. I'm going to go back to my model tab, and I have to put in an axis. So to do that, I can grab not my front plane, but my top plane and my right plane, and I can put in a reference axis. And it should let me do that. There it is right there. Do you see it? Okay. Back to analysis. External load, a torque. It knows what axis because it's the only one. So there's my torque there. I need to put that in English, which is in pound inches, and that was 1,000. Got it. There's that. Run this study. I hope my answers are good. What did I have? A von Mises of 23 something. It's not running the study. Oh, I got it. There it goes. Valid for static analysis. Switch to plasticity. Who put that in there? I must have checked the box. I didn't realize I checked. But they're solving it for me. Von Mises stress is in PSI. Doesn't do me any good. Edit definition. Ooh, that's a lot higher. A lot higher stresses. A lot higher stresses. Remember, I was at the 23,000 in the other code. So I got a couple more. I got a peak going on there. Displacement in millimeters. I can figure that out. But edit definition. Inches. Got it. 0.101. 0.101. That is actually closer. That is actually closer. Oh, no. That's, yeah, it is closer. Sorry. Inventor solved at 0.099. I got it right over here. Let me grab it. Inventor. Oh, I got to go back to analysis. Inventor gave me, sorry, URes, X displacement. Oh no, the total displacement. Let's be fair. So they gave me 0.09946, and this has 1.0 or 0.0, no, 0.101. So this is like 2% closer. So now I'm only off by 6%, give or take 5. Little different, but my stresses were a lot worse. Maybe my von Mises stresses. I also bet my mesh is really ugly. So I should do a show mesh here and go, oh, what's it got for me? Oh, that's actually fairly aggressive. I'm kind of surprised. Let's take a look at stress. Let's define a stress plot. I think our stress plot that was interesting was the shear in the Can I do principal shear? No. Stress on Z in the YZ plane. No. I want to stress on let's try that in PSI. 1692. Those are high. I calculated 12, 13. So these are coming out really high. And that's interesting because they should match up closer. My stresses should be, if my deflection's matching that close, my stresses should be closer. So kind of interesting what's going on there. But yeah, these are 25% off on my stress. My stress was, I got to go back to, I still have my pad of paper. That's the cool thing about paper. My hand calculations are 12.65. Let me define another stress plot. I'll pause you. Yeah, so I just don't have the agreement that I'm looking for here in the stresses. I've got 17,000 compared to my answer, which was 13,000. You can see the time, 10:18. I'm publishing this and getting to class. I would go back and check my mesh. I would go back and do more with the mesh, change that. I don't think that's going to change my answer. I don't think I'm going to get to a better place, unfortunately. And that's really interesting. It would take some playing to figure out. It may be that little warning I got that this is plastic deformation, that this is treating this a different way, and I've got to check some of my solving parameters. But I did have decent agreement on the displacement, which, since we know the displacement is the strain and the stresses are the forces. If I have accurate agreement on the displacements, those are related through Young's modulus. It could be my Young's modulus that I didn't check is way out of whack. I don't know. I'll give it a quick look. That's the last thing I do before we button this up. Apply edit material. Or not. I'm just going to button it up. So you guys can, 60, 61. Shear modulus 377. It's a little higher, but that's not the reason for my stress problem. I don't know. All right. You guys take care. See ya.